Okay, so let's begin to the afternoon session now. And so in this first half of the afternoon session, we will learn how to run the jobs and compose the code to execute on supercomputers. So we are starting again from page 45, 46. So here in this slide, so in the following 3 slides, I am indicating here what we should run for supercomputing. I am assuming 3 typical cases. One is when you want to write a new program code or speed up an existing program made by other people. So typically, in many scientific programs in the field of physics, engineering, or relevant area, hotspots of the programs are iteration part. For example, this is written in Fortran style. So we have do iteration. So in such a loop operations, we are doing similar types of multiple and again and again. Similar kinds of operations are repeating. So such kinds of parts are typical hotspot where we can make a speed up by using appropriate optimization of the program. So we should rewrite the programs in a way that is friendly to CPUs. So in the last Q&A session, there was likewise, a question from one participant. But we should always think of how to effectively realize SIMD operations on CPUs, or how to effectively utilize the cache memory of the CPUs, not the main memory, but the memory which is close by to the computation cores. And also we should improve memory alignment. And also we should think of, when using supercomputers, increase the number of CPU cores. By using the distributed parallelization. So this is a wrong notation in this slide. So distributed parallelization by using OpenMP and or MPI, message passing interface. This is what we should think of second. And third, we may utilize libraries for scientific computation, which has already been made by other people, which is fully tuned and parallelized for the usage on supercomputers. So by these techniques, we should try to speed up your program or a program available from other people. Second case, how to use, so we may think of how to use existing software for supercomputers. So either in open source or sometimes we used to purchase softwares, but there exist such kinds of softwares which is highly parallelized for supercomputers in the field of typically in computational fluid dynamics, structural analysis, statistics, molecular dynamics, or in physics, electronic structure calculations, or quantum chemistry. So, so there are actually many available softwares, and it is important to know how these softwares are parallelizing the tasks. Of course, we cannot read the whole simulation code, but through this experience of using them, we should by ourselves distinguish what kind of parallelization is available in these softwares. And then we should make effort to know how to derive the best performance from these softwares. Third case, typically such kinds of demands are increasing recently. I mean, data processing in machine learning or deep learning. So in this case, we needed to know first the data processing via Python, how to treat the data in the Python language. It's because machine learning is most typically implemented in terms of the Python language. And also, if we want to use supercomputers for machine learning, then we need to know environment settings specific to supercomputers, including the parallelization over multiple GPUs. This is actually involving very technical issues, so specific, which are specific to supercomputer types. So in general, it's difficult to do by ourselves. And this is actually purpose, the reason why I have prepared the course for machine learning in the latter half of this afternoon. And I will explain and let you know how to run such kinds of machine learning on supercomputers. This is actually a special thing to run. And sometimes some container, so-called container environments, which is optimized already for supercomputing infrastructure, are distributed. So we can sometimes use containers depending on the situations. And also, we needed to know how to use the batch job, because very typically, if you are using machine learning or deep learning, you are doing tasks on or using GPUs on your desktop. So maybe you are frequently doing a GUI interface using GUI, graphical user interface. But on supercomputers, only command line interfaces are available. So we needed to know how to write JavaScript in text and order the supercomputers to do the task. And honestly speaking, supercomputers in universities are actually in comparison with cloud services provided from the private sectors. Environment settings are a bit annoying and complex. But for the people working in the academic field, using university supercomputer is still a good way because they cost far cheaper than such private sector services. So it is worth learning how to do such tasks on supercomputers. We are we are actually having many times, about 10 times, more than 10 times in 1 year, we are having workshop or tutorials to guide you how to effectively program parallel programming on CPUs and GPUs. But I am showing the list of the courses running at Information Technology Center. All are free, but unfortunately, all other tutorials other than this current workshop are held in Japanese languages. Some basic courses perhaps will be made into English, but still, unfortunately, they are in Japanese. So if you are good at the Japanese languages, please consider taking these courses. So again, I am showing how to use a supercomputer in the form of a figure. So we are now up to in the morning, you have successfully logged into the login node of the supercomputer. This is a kind of entrance of the supercomputer system. But still, we have not computed any tasks. And actually, to compute on supercomputers, we need to order the computer nodes to do the tasks which you desire. So for the program execution, we need to make an order to computer nodes from the login nodes. This process is a job submission, which we will learn how to do. So this is the current subject of the study, job submission. Yes. And before submitting the job, so we need to write the code. So we need to learn how to use editors. In this tutorial, because the time is limited, I assume that all the participants are used to do composing text files by using Emacs VIM or none. Yeah, and also you need to learn how to use commands on Linux system. So I am showing very typical commands, and I expect that most of you know these commands. So I'm going to the list. So pwd is for showing the current directory you're working in. cd change the working directory into the specified directory. And ls displays this list of source files. Sorry, many misspelling existing. cp copy and rm delete exit. So exit is special on supercomputer environment. If you type exit, then so session session in the terminal will end. And when you are logging into the supercomputer, it means that you are logging out from the supercomputer. Other commands are also shown. Please refer to them when you need them. Need this information. I skip this now. And also, so on our Oak Ridge CX supercomputer, the default shell is set to bash. So perhaps some of you are used to Dish or other shells, but please keep in mind that we are using bash on Oak Ridge CX system or other supercomputers at the University of Tokyo. So for bash, some tools facilitating the command inputs are available. So for example, if you type tab on the keyboard, then so autofill will work, which means so automatically the rest of the commands which you have partially typed will be complemented. Or if you're typing how to say up arrow, it will display previously executed commands one by one. Or you can also make a history search, or write the output of the command into a file by redirecting, while you can also use a pipe. And it is probably worth mentioning that most supercomputers in the world are operating on Linux operating system. At least on the top 500 list of supercomputers, we can only see Linux systems operating on Linux system. And as a marked feature of a Linux operating system, all the components are open source. And we can basically do all the operations only with command line interfaces. Perhaps you are using Linux also on graphical user interfaces, but on supercomputers, typically we operate on command line interfaces. the file system based on directory structure, so which is corresponding to folders on Windows or Mac operating systems. So again, I say editors. I assume that you are used to the usage of the editors, and I am assuming 3 editing tools: Emacs, VIM, and none. I hope that you can at least use one of them. You can use, and I am skipping how to use these editors because of the limitation of time today. So we are going into the main part. So I'm showing the Linux directory structure on the Oak Bridge CX system. This is actually a special thing, because if you remember, I hope you remember that the first directory you are moving to is home directory, home/t blah blah blah. Just after the login, you are redirected into this place. But actually, the supercomputers at the University of Tokyo has a special setting because compute nodes cannot see home directory. So actually, the file systems are so we have one, as I mentioned, we have one big file system which is called raster storage, and the whole system is connected to the raster storage. But the special setting is that home directory is not exposed onto the computer nodes. It means that so we should use another directory which we call work here. So actually, so the raster storage is actually pointed by this directory. So how to say? So by moving to work, so you can move on to the raster storage, and home is not the raster storage. This is a special thing, and computer nodes can refer to raster storage. So I think I have already explained that raster storage system realizes first write and read, and it has very large capacity of larger than 10 petabytes. And the most important thing is that all the jobs should be run from here, work directory. You cannot run your jobs, nor you cannot submit your jobs from the home directory. This is a special thing. The reason for this setting is that sometimes the raster storage is in trouble. So they are not always, fine. Sometimes there are technical troubles. So after login, if we set the raster file system as the home directory, after login, you cannot see the system setting. This is somewhat annoying and troublesome. So we are separating the raster file system from the default login directory, which is the home directory. This was the important part. So any question up to now from you? Is it all right with you?
Sensei, I have a question about
thank you, please.
This file system.
Yes.
So the on the compute node, when they are running the job, so at some point they need to access user data. So my question is where are the user data located? In which file system? Home or work?
Actually, so you should put all your programs, all your data necessary for simulation, all the data generated from the simulation, all the data should be located in work. So
I see.
Effectively for computation, home is no use actually.
Okay.
Funny thing, but all so please put everything onto your work directory.
So in home directory only job script, but data.
No. Even job script should be put onto work.
Okay. I
So
see.
natural question is, what we should we run on? What we should put on form directory? This is a kind of very typical question that I have actually no answer.
Okay, I see. But this
Sometimes
is good
we
to
are
know.
asked, what is home directory for? This is actually a difficult question for us. But you can put some small data on home as a backup, or you can keep your, for example, you can synchronize the home directory with your, for example, Git repository, for example,
Yes.
repository or something. So, and the home usage can be assumed to be, directly connected to internet. So,
I understand.
may be able to find some purposes.
Okay.
Right.
Thank you very much.
Okay. You're welcome. Other questions, please. Of course, Japanese language should be okay. I will translate. Right. So I forgot to mention that your work directory is actually have the so it should be identified as like this. So work /GT00 /T and your username. So in this lecture, in the account which is distributed for this workshop, you are associated with the group ZT00, and you have the personal directory inside this ZT00 group directory, which is named T and user code. This is a special thing. So, let's go on to the hands-on. So please launch your terminal again and please log in to OBCX. So first thing is if you are not on the OBCX system, you should do SSH connection like this. Then please verify that you are having this this type of terminal, T username at OBCX 02 or 01 or something. Then as first we probably had better confirm existence of your own directory. So please type /cd space /work. Is the letter large enough? Maybe I can make it a bit bigger. So the T00700, this is my ID, and you should type your ID here. Then please verify that you have your own work directory. So by PWD, you can confirm that if you are actually in the working directory of yours. Then get back to the home directory by CD. Yeah, so this is first thing, and we are now at the page 58 of the PDF. So we will from now we will compose an example program and then write a job script to let the computer node compute something, which is Fibonacci sequence. This is very easy computation, no use for using a supercomputer, but it's please consider that this is just a practice for ordering the computer node to do some task we desire. So Fibonacci sequence is a kind of defined as a recurrence relation by a recurrence relation. So 0 plus 1, 1 plus 1 equal to 1 plus 2 equals 3, 2 plus 3 equals 5. So this is a kind of typical iterative computation, and which is a starting point for using supercomputers. So we repeat and repeat this summation. So our task is to compute this sequence up to 90 seconds. I don't know how many precisely digits here existing. And our task is compute this sequence and then find the sequence 747031 in the result. This is our task now. We want to do now. So let's compose a program using the text editor. I assume that you can use either Emacs, VIM, or Nano. So first, let's make a directory inside your work directory where you can work on composing the program. So as I mentioned, all the programs should be put on work, but let's start with composing the program on your home directory and then copy to work directory. So please follow me. So you should first verify that you are working at the home directory of yours. Then create a new directory, Fibonacci. Then move to this directory. Sorry, I have made a mistake, misspelling, like this. Then let's compose a program. So you can either choose you can choose either one in Fortran, or in Python, or in C. You can compose it. You can choose any programming language. Please choose one and compose the program. The program actually is shown in the pages 62 to 64. So you can just type again by using the editor. So, for example, if you compose a Fortran code using Emacs, then you should type Emacs space Fibonacci .f90. If you compose a Python script using VIM, then you should type VIM Fibonacci.py and then return. If you want to compose a C code, then you should do nano Fibonacci.c and return. So I will compose a C program by using Emacs. So in my case, Emacs.space Fibonacci.c. Then just so I assume that you have already in your hand the PDF. Then you can refer to pages either one of the pages 62 to 64, and then manually type the same code inside. Sorry that my letters are in a weird color, so it's hard to see. Probably, I'm sorry for this setting. Probably I should change the color of the terminal, probably. Then I will abandon this terminal. So please type your program in a language which you desire. So I finished. Then I can go to the next stage. So maybe I should wait a bit moment before you finish, until you finish. So if you are prepared to go to the next, please raise a hand by Zoom. Then, so if you are ready, we would like to go on to the compilation of your program and the job submission. So first thing first thing to confirm is what kind of compiler you need. So on Oakbridge CX system, you have the choices of, for example, GNU compiler or Intel compiler, which is optimal for compilation on Intel CPUs. Or you may if you are using Python, we do not need compilers, but just we need Python interpreters. And also, for now, we do not need it, but we may want to choose additional libraries for accelerating computations. For example, fast Fourier transform, so-called FFTW, or linear algebra packages like LAPACK or something, and others. So such kinds of compilers and libraries can be on the Oakbridge CX system, can be chosen by using the so-called environment modules. This is the important thing to learn here, environment modules. So please get back to your terminal. And then type module list on your terminal like this. So you will find this message. Currently loaded module files are Intel MPI and Intel compiler 2020.4.304. So these are indicating that you can use the Intel compiler. So actually, for example, if you use the command for Intel compiler, which is ICC, then you see that. So if you cannot use the compiler, then it should show no commands like this. But actually, so ICC is existing on your environment. Then command line error, no files specified. So we need to specify compile program for compilation. So first, let's try to erase this setting. So by typing module purge, and then again typing module list. Yes, so we can find that no module file currently loaded. As a result, you cannot find ICC. So Intel compilers cannot be found because it is erased out from your local environment setting. So these environment modules can be operated by the command module, and this module command can set up what kind of tools or compilers or libraries you want to use. So this is actually important tool for using supercomputer. Any questions? Do you have any questions now? All right. Actually, I mentioned a very important thing today. And sorry. これは the moment I want to erase this. Okay. So by typing module avail, so you can get a very long output like this. Actually, this list is showing what kind of tools are available now. So in this list, for example, you are see in many versions of Intel compilers, for example. Also, typical one is, for example, you can choose Python also, Python 2, version 2.7, or by Python version 3.7 or something. Or a kind of container environment software, Singularity, or usual GNU compiler GCC, or other tools. Part2, this is an performance analysis software attached with Intel compiler. Actually, much more tools are available, but for some reasons, which is module dependency, we cannot all the choices just by showing module available. So this command does not show all the available choices for the modules. So we on our oak bridge system, we have original command show underscore module, which shows all the available tools on this supercomputer. For example, if you want to use the for example, what is appropriate? GNU scientific library. So this may include probably TW or layback. So we can load GSL or HDF5. This is the file IO2, or some also application softwares are available. For example, GLOMAX. This is molecular dynamics software, or OpenForm. This is Fluid Dynamics open source software, or Paraview. This is a tool for a visualization. So many tools are also available via this environment modules. So you can call compilers, you can call libraries, and not only this, you can also call actual applications which you want to run on the oak bridge system. So you can search for the tool you want to use by typing this show underscore module command, which is originally implemented for this oak bridge CX system. Yeah, so so this slide is just showing the usage of module command. So we have already seen how to use module avail, module list. So these respectively show available environment modules and currently loaded environment modules. And the module load and the module unload can change the setting of the environment module, which is also. And the module purge, this will erase all the current modules and load, and so we can change into the all the modules unloaded. So for example, if you want to use Python 3, so you should type module load Python /3.7.3. So here, let's try module loading a previous version of Intel compiler, 2020.1.217. Module purge, then no module files currently loaded. And from this null status, we can we can load modules of Intel compiler 2021.217. Then module list. So together with the Intel compiler, Intel MPI library. So this is a message passing interface library. It's automatically loaded together. Also, for the Python users, we should also load Python 3.7.3, the module list. So in addition to the Intel MPI library and the Intel compiler, Python becomes also available. Actually, so if we type Python 3, then we can launch a Python interface. You can confirm this. Yes. So, okay, the next thing is to how to job submit. Next thing is to submit the job from the login node to computer node. And this is the next thing to do. And so maybe the order should be changed. And so there's a bit of changes in the page number. Please be careful. So first, and then job submission part. Running your jobs on OPCX. Okay. All right. So let's compile the program first. And actually, for Python users, as many of you may know, Python does not require compilation. So if you have composed C or Fortran programs, then you need to compile the code to generate the executable binaries. So if you have composed the program with C language, so first, please verify that you, Intel compiler is available by module list. Then please type ICC Fibonacci.c-o Fibonacci.out. Then you will get the executable file Fibonacci.out. If you are using Fortran, please use ifort instead of ICC. Then do the same thing, Fibonacci.f90-o Fibonacci.out. So because I have composed the program by C, actually I have Fibonacci.c here. Then we can compile. I can compile Fibonacci.c. Misspelling, sorry. Like this. Then by typing ls, I can confirm that executable is generated, Fibonacci.out. And on Oakbridge CX system, you can use either Intel compiler or GNU compilers. So if you use Intel compiler, you should type the commands ICC or ifort. And if you use GNU compiler, you should use GCC or gfortran. And we will later practice how to run MPI codes, message passing interface parallelized code. And in this case, you should use, for Intel compilers, MPI ICC or MPI ifort for C and Fortran, respectively. And if you use GNU compiler, so you will call a command npicc or mpif90. And I have shown typical options for the compilers. Because it is not the main interest in this workshop. This is important to learn, but it's not the topic in this tutorial. So I skip detailed explanation for this. So next, after compiling, we need to create the JavaScript. So JavaScript is a kind of instructions from the login node to computer node. So it instructs what computer node should do. So by writing this script and submitting JavaScript, then it is thrown into the computer node, and the computer node will execute these subscribed, yeah, they do what they are ordered. So because I am using C, I will create Fibonacci.sh in the form of this script in the left. If you are using Python instead, please change the last two lines into this one, module load Python and Python.Fibonacci. Okay, so please, as a practice, please type the JavaScript. So actually, every line has its meaning. The second line, so it specifies the resource group. Resource group is a kind of group of nodes are specified with this. So we are using actually the small number of nodes as a group. Then so we are ordering to assign a node belonging to this tutorial group, and we will only use one node. This specifies the number of nodes which will be used. Then also maximum elapsed of time is set to 1 minute. If the job is exceeding 1 minute, then this will forcefully end it. And ZT00, we are in this tutorial workshop, we are belonging to ZT00 group, and this should be explicitly specified. And hyphen large N is not important. This is just a job name. And hyphen O stood out the text. This is specifying the file name where the standard output of the program is written into. And PGM hyphen J. This is orders that the error message should also be written into the same file stood out text. Then so the following is the actual command which we want for the compute node to perform. So we are ordering the compute node to execute these commands. So first, important thing is that we need to specify that we will use the we will run the binary which is compiled on Intel compiler. So it is important that we specify the same environment setting via the module command. Because we have compiled the program by Intel compiler, then we should specify Intel the appropriate version of the Intel compiler here. Then execute the Fibonacci.out binary. That's all. Then save and exit. For Python users, we need to just specify Python 3 via the module command, then execute Python like this. Any questions? All right. So if you have successfully finished the job, finished submitting the job, soon after submission, you will find stood out text in your file. Just I am working on the same work directory. So by typing a cut space stood out text, then you can find that Fibonacci sequences are actually computed like this. Then the original task was to find 747031 in the result. So we use grep command, grep 747031. So find this sequence. Stood out. Why stood out? I think I made one fault. Sorry, this result of Fibo is, I don't know why it's happened. Sorry, my PDF is wrong actually, but I guess something happened. Just stood out the text. Then we can verify that this sequence is existing inside the text as expected. All right. Yeah, so on page 18 of the slides, indicates how to manage your job. So we have just used PJ sub. So this is to submit a job, PJ del. So we can, if you know the job ID, you can delete the job, and you can query the job ID by typing PJ start. So just we can try Fibonacci.sh again, and then PJ start. So my job is, we can see by PJ start command, we can see that my job is waiting. It will soon finish. So maybe, but still good. So maybe this is a bit of crowded. So PJ start node use 032. What is happening? Okay, finished. A bit time lag is existent. Okay, then again, I am submitting Fibonacci.sh, then I can delete this job either. Yeah, so PJ del job ID number cancelled. So we can stop the job before it complete running. Great. So we are actually using a tutorial resource group, but for after this workshop, so tutorial is only available today, 1 to 5 p.m. And it should be changed into lecture resource group after this workshop finishes. And for 1 month, you can test and try, submitting any types of jobs. Okay, because the time is a bit in short, so we wanted to go to next session. Do you have any questions up to now? Okay, so please lower hand, thank you. So the next exercise is to compute some number by numerical integration. So just this is indicating how to get it. This is the object I want to integrate. Then we will get pi. So the task is to see whether the computation will speed up or not. And we prepared 3 sample programs in the language, the C, Fortran, and Python. So the exercise is to measure execution time for various degrees of parallelism. I mean, change the number of CPU cores we use, then we measure the speed up of the program. So we will use the message passing interface. So understanding this MPI is not our focus now, but we try to just run this types of program. So this is slide is just showing why we can compute pi with this integral. So I have prepared 3 sample programs which are available from. So we will not request you to type these codes explicitly, but just I will ask you to copy from the specific place indicated later. So C source code. So this is a serial program. Just repeating summation by for loop. And so if we parallelize this code with message passing interface, then we explicitly specify how the for loop should be divided by writing so this for loop is specifying which part of the iteration loop should be solved by each CPU core. So on each CPU core, independently, these programs are running. But because different regions are specified, then different summation is done in each core. Then finally, we will sum up all the results. So collect all the summation from all the cores, and then finally we sum up the result. Then we get pi. This is what we do. And for comparison, because this is MPI program, So it's actually includes code for MPI library, MPI init, MPI command also, likewise. So we should compile this with MPI compiler, MPI ICC or MPI iFort. Yeah, so this is the Fortran. Just noteworthy thing is because the summation length is quite long. I remember this is a kind of sub-billion. So actually, default 4-byte integer cannot treat this. So we should specify that this is this is specified by 8-byte integer larger number of digits than 4-byte character, digits. So we are adding _8 here. And then basically the same thing is done, just the task is divided into each core. And then afterwards, we will sum up all the result over the cores. In Python, Python is a kind of a bit special. So this is Python code implemented with MPI. But we need to call an additional library, which is called MPI for Py. And then we will do the same thing. So just divide the for loop like this. Then finally, we will sum up the result. Then, and in all the programs, we are finally printing out the result. So to verify, actually the pi 3.1415 is calculated, and then number of cores utilized. So this is in blocks means the number of MPI processes, which is equal to number of cores. Then finally, we display execution time. So we will change the number of cores, then measure the execution time. And in all three codes, such results are displayed. So first thing is to copy the code into your own work directory. So just follow the instructions. And depending on which languages you are using, please please choose either one of three options. So and type this Py. So which maybe it's better for me to choose Python this time, but you can use C or Fortran or Python, either one. I made a mistake. I forgot to do this a bit moment. So first thing is to create one directory PyMPI, and then verify that the directory is newly created, and then already we are working in this directory, sorry. Okay, then copy the program. I will choose Python. Yeah, just copy and paste from the PDF is also okay. Okay, then you will find about 10 files inside these directories if you have successfully copied the program. Okay. How many people will be choosing Python? Please raise a hand if you are choosing Python. Okay, 1, 2, 3. Okay, 3, 4, 5. And okay, so for Python users, please wait a bit moment. I will first guide for C and Fortran users. So just please compile the program by MPI ICC or MPI iFort as indicated here, depending on your choice. Then then just because JavaScripts are already attached into this, you have also copied the JavaScripts into your computation the working directory. So you please submit these 6 job scripts. So actually, I prepared the job scripts for running on 4 cores in one node, 28 cores in one node, 56 cores in one node, and 2 nodes, 4 nodes, 8 nodes. So we have 6 patterns. And please do all these job submission. Then verify what kind of results you will get. This is the thing you will do. If you have any questions, please stop me and ask questions. So I will turn into the Python users. So for the Python users, it is a bit difficult, complicated, because we need to first prepare MPI for Py package. This is a special thing to do. First, please verify that you are loading the Python 3 module, Python /3.7.3. This is necessary. And then please find set.env.sh and edit this and change your change the part here into your ID like this. So actually, this is specifying where to install the Python library. But if you do not understand, please forget. Just change this file and you edit into your own ID. Then run this set.env.sh. Sorry, I made a mistake, not set.env.sh, but we should actually run setup.sh. This is a mistake of mine. Like this. Then it will take time, and it will automatically install MPI for Py, which you can use. Some error message will appear, but you can ignore these. Yes, you can see MPI for Py package is downloaded and installed. First, the package file is built, and then it will be installed into your local user directory for Python. It will actually take time, and I guess you are already doing this. Yes, then if you have successfully installed MPI for Py, it's ready. You are ready to run a Python script. So if you are like, so in the directory you have copied from the one which I have prepared, you will find 6 job scripts here. So let's run all the job scripts. I will first verify that I am downloading the correct one. Yes, sure, it seems, yeah, perfect. Then, yes, so you can submit all the job scripts. I made a mistake. 112. No, and 2. Sorry. And 424. And 8. 448. Some of them will take time because we are submitting a bit to too many some jobs are submitted now. So you will be made to wait for the jobs to end. Yeah, certainly it will take time. So please patiently. But running, so it's not crowded so much. All right. And yes, so yeah, the results are currently being written with the file name result underscore blah blah text. So for all the users, either you in either case using C, Fortran, or Python, you must be getting 6 new files result.txt like this. So by using the wildcard asterisk, we can see essential part of the outputs at once. head results. Asterisk text. So we are seeing that with changing the number of cores utilized from 4 to 448, the execution time is becoming shorter, which is indicating that we have successfully speeded up the program execution by using many nodes. So if you have finished with this, please try to write the results into the chat message. I will show the example. Excuse me, I'm sorry. We can share the results. Like, first we should indicate which language we are using, and then please have a look at the chat. Then, so we can share the results. If you have finished, please type your results into the chat. Then I have, so I am using the Python. Then with the 4 cores, it has taken 53 seconds. You can see in the chat. Then finally, with 448 cores, it is shortened into 0.6 seconds. Okay. So I'm sorry for the extension, but this is actually, we have finished with the first part of the hands-on. So we are taking now 20 minutes break and then restart. And in this break time, I would like to take your questions, or I would like to help you together with the other staffs.